Let's try to understand what is a degree and what is an order for a differential equation. Alright. So first what we'll do, we'll look into order. Okay. So here, so first thing what you are doing, order of a differential equation. Correct. Now imagine you have a differential equation, something like this. Alright. Say you have dy by dx. So y into dy by dx plus d square y by dx square is equal to sin x into dy by dx whole square. Okay, assume this is some particular differential equation. Now there are two important parameters which defines a differential equation. First one is order, second one is a degree. Okay. Now order. Now if you look at the differentiation part, what we have done, we used to call it as derivative. Next one we used to call it as second order derivative. Right? See that? Second order derivative. That means whenever we talk about order of a particular differential equation, we need to look at that particular differential equation in which the derivative has to have the maximum value. That means maximum derivative. In this example, which one has the maximum derivative? This is d square y by dx square. Now this is a second order derivative, isn't it? So order becomes 2. Now let me repeat what is the order. Order is that particular parameter in a differential equation where it is differentiated maximum number of times. That is basically an order in a differential equation. So in this case, the maximum differentiated term is d square y by dx square. So the order is 2. Suppose if I give you another example now. Alright. So another example. Let's say you have x square y plus y into d square y by dx square is equal to d cube y by dx cube. Now if I ask you what is the order of this particular differential equation, which parameter is differentiated maximum number of times? So we have this. How many times is it differentiated? 3 times, correct? So the order becomes 3. Clear? So the order becomes 3. Now like this, if you try to understand degree of a differential equation, so we'll do one thing, we'll write the degree part here itself so that you understand how they are related. Degree. Now all of you understood what is an order, correct? The maximum number of times a particular derivative is differentiated. That represents the order of a differential equation. Now, when it comes to degree, see the power of the maximum or maximum number of times the differentiation is present, as in the derivative is present. In the sense, look at the first example. See in the first one, the order is 2, correct? For that particular derivative, what is the maximum power? That is what we are looking at. Okay, let me repeat this again. If you look at the order of the differential equation, you are looking at the highest derivative of the differential equation, correct? Look at the power of that particular order, or look at the power of that particular derivative. So here, my maximum derivative is d square y by dx square, right? What is the power of that particular parameter? 1. That's nothing but this to the power of 1, isn't it? So in this case, the degree becomes 1. Even in the next case also, degree is 1 only, because the highest order is d cube y by dx cube. For that, what is the power? 1, right? Now let me give you one more example so that you'll understand it much more clearer. So what we'll do is, we'll try to calculate the order and degree both, okay? Both of them will try to calculate it. suppose, say, you have, the question is this, y into dy by dx whole square plus d square y by dx square to the power of 2 is equal to d cube y by dx cube to the power of 3 into, let's say, y cube. Some random some random equation I've given it. Now in this, first let's try to find the order. Order is what? Whichever has the highest derivative part. That means here the derivative is nothing but this, isn't it? So order becomes 3. What is the power of that particular derivative? Power of the particular derivative is 3. So degree is also 3. Okay, degree is also 3. So not necessarily always the degree has to be 3 or 1 or whatever it is. It can change because look at the previous examples. Here the order is 2, degree is 1. Order is 3, degree is 1. So it entirely depends on the question or the problem what I have given it to you. I hope this is clear about what is an order and what is a degree. Because in the next video, we will solve few problems in trying to calculate what is an order, what is a degree. Okay, now before that, let me give you one example where the order is not gonna exist. Okay, like where the order is not even there. Let me give you that example. Look at this example. X plus y square into d square y by dx square is equal to sine of dy by dx. See, in this example, we can't really calculate what is the degree and what is the order and everything. You might say that, yeah, why can't we do it? Because d square y by dx square is right outside. The order is 2, degree is 1. You can tell that. But that sine of dy by dx is there, right? That is going to change the entire differential equation itself. Fine? So whenever we have a function and the derivative is a part of the function, like in the sense if the derivative is actually one of the parts of the functions, then we don't say that we have a degree or order depending on how it is. Understood? So this is an exception what you can say. Fine? Now in the next video, we are going to solve few problems based on finding the order and degree. Alright, once you are done with that, we'll see how the order moves, how the degree goes, and what is the order of particular type of differential equation. We'll solve some problems in the next video.